This is Geometry 9.3a. We're going to write equations of circles. Just like a line, where we talk about y equals mx plus b, there's two things you need to know about a line. You need to know slope and y-intercept. Well, there are two characteristics you need to know to define a unique circle. You need to know the center point, which is considered h and k, and you need to know the radius. The center point tells you the location, and the radius tells you the size. So to write an equation of a circle, we have x minus h squared plus y minus k squared equals r squared. That's our standard equation of a circle. H and k are the center, and r is the radius. Now what's going to happen, notice that the formula here is x minus h. The minus essentially is going to make the equation look opposite than what it is. If it is x minus a positive h, then it's going to say x minus a positive number, like x minus 2. That means the graph is translated to the right. If it says x minus, it's translated to the right. If it said x plus, it's translated to the left. It's always opposite of what you think because the formula is a minus. We'll talk more about that as we get there. So here's our center. Our center is considered h and k. Our radius is 6. So if we take our equation, x minus h squared plus y minus k squared equals r squared, we're going to plug in the 0 for the h, the 0 for the k, and the 6 for the r. X minus 0 squared plus y minus 0 squared equals 6 squared. Well, x minus 0 is just x, and squared is going to be x squared. Y minus 0 is just y squared, and then 36. 6 times 6 is 36. There's your equation of a circle. If we come over to Desmos, let me see if I can change this up a little bit. We can take a look at Desmos. We can type in our equation. We just had x squared plus y squared equals 36. And that would be our circle. It has a center point at the origin, and it has a radius of 6 units. So you can type these equations into Desmos. It is possible to type them into a graphing calculator. It's a little bit more complicated because a graphing calculator is only y equals. So now we're back to the notes. Here's another one. We have a center at negative 5, 2. So if you think about your graph, you're going to be at negative 5, positive 2, with a radius of 2. So you're talking about a circle that would look something like that. What is the equation of this circle? Well, we have our h and the k, and our radius of 2. So we're going to say x minus our h. Now notice what happens here. We have x minus a negative h value. So then we need that all to be in parentheses. Y minus a positive 2 squared equals the radius squared. Now this is going to become minus a negative, which is actually a positive. So x plus 5 quantity squared and y minus 2 quantity squared equals 4. That has a center at negative 5 and a radius of 2. Notice that the equation is x plus 5. When the graph is moved to the left 5, the equation is going to say x plus 5. When the graph is moved up 2, the equation is going to say y minus 2. It's kind of opposite of what you think. And the reason that is because the formula of the equation is x minus h, so it's the opposite. Y minus k, it's the opposite. And we can plug this into Desmos. We can get rid of our current equation. We had x plus 5 quantity squared plus y minus 2 quantity squared equals 4. And there would be our circle. The center would be at 5 to the left and 2 up, and the radius was 2 in every direction. The radius is 2. So you can type these into Desmos. Back to our final one here. We have a center at h comma k. Oh, this is a diameter of 10. If the diameter is 10, then that means that the radius is going to be half of the diameter. The radius is 5. You need to concentrate on what's important. You need a center point and you need a radius. So if the equation of a circle is x minus h squared plus y minus k squared equals r squared, we know our center is at 0, negative 3. So x minus 0 is for the h, and y minus k value is negative 3, and our radius is 5. So x minus nothing just gives us x, and it is squared. This is the y minus a negative. Y minus a negative actually is y plus 3, and it is squared. And then we have 25. And we can type that into Desmos. Or you can just mentally, you're just thinking about what this means so you have a good understanding of what's happening. We're 0 and down 3 with a diameter of 5. So it should look something like that. So if we redo our Desmos and make it x minus 0 squared plus y minus 3 quantity squared equals 25, So apparently our equation was plus 3. There it goes. It's a little bit better. So our center is at 0, -3. So 1, 2, 3. There's our center point. And we have a radius of 1, 2, 3, 4, 5. To the left, to the right, down, and up is all 5 from the center point. And back to the notes. Let's take a look at what we have here. Now we're given the circle. We need to come up with the equation. So for our circle, what we need to know, what would you suggest we need to know to write an equation? We need to know the center, which is an h, k, and we need to know the radius. And then we're going to square it. So our equation, remember, is x minus h squared plus y minus k squared equals r squared. So when we look at our first example here, we see our center is at 0, 0, and our radius is a value of 3. So we can write our equation x minus 0 squared plus y minus 0 squared equals 3 squared. Well, we don't need the zeros in there because x minus nothing is just x. So we have x squared plus y squared equals 9. You could try typing that into Desmos to see if that creates the same exact picture. You'll know if you did it right. Here, I'm trying to figure out where the center is. So you take the widest location and you go across. And then you take the highest point and come down. So my center is right here. 1, 2, 3, 4, 1, 2, 3. So my center is 4, 3. And my radius, the distance that it takes to get to the side, looks like 2. So I'm going to have x minus 4 squared plus y minus 3 squared equals 2 squared, otherwise known as 4. Notice that this says x minus 4. That's telling us that it's moving to the right 4. It's opposite of what you might think. And y minus 3 is telling us it's moving positive 3. It's moving in the positive direction. The h is a positive, the k is a positive. But the equation is going to look like x minus 4 and y minus 3. And we come over to our next one. Look at the widest point out here. Here's your widest point. You're going to go straight across. You can do it with your eyes if you can. Look at your highest point and come down. So your center is going to be there in the middle. So that's 1 to the right and 1 down. So my center is 1, -1. And my radius is the distance that it takes to get to the side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 5 in every direction. Because the radius is the same no matter which spot of the circle you go to. So to write our equation, we're going to have x minus a positive 1 squared plus y minus a negative 1, and you square that unit. Notice I put the negative 1 in parentheses. Then we have our radius squared. Nothing can be changed here, x minus 1 squared. You cannot distribute that. You cannot call that x squared. You would have to do a whole FOIL part to it, so we'll just leave it. Plus y plus 1, because when you minus a negative, you get a positive. Still squaring it. 25. We are 1 to the right, because it's x minus 1, and it's y plus 1. That means you're down 1. To the right 1, down 1. All right, let's try to graph. Now we're given the equation. What's the graph going to look like? Well, to graph it, what do you need to know? You need to know the center. You need to know where the center of the circle is. And you need to know the radius, which tells us how wide it is. Center tells us location. Radius tells us size. The center is going to be 0, 0. And the radius is going to be the square root of 25. Square root, because our original equation is r squared. So the radius is 5. So we're at our center, and we move 5 to the right, 5 up, 1, 2, 3, 4, 5. 5 to the left, 5 down. Now the magic thing with 5s is you can do other Pythagorean triples. I know that if I do 3 and 4, I land at a perfect distance of 5. Or 4 and 3, I land at a perfect distance of 5. Down 3 over 4, down 4 over 3. Same thing going the other direction. So it helps you make the connection. Notice how wide you got to get when you're drawing your circle. And you have your circle. We don't always get those extra points to plot, so don't worry about that so much. But we're over 5 to the right, over 5 to the left, 5 down, 5 up, you draw your circle. But we've learned about right triangles before, and a 3, 4 would require a hypotenuse, or the longest length, of 5. When we come over here, we see that our center is at 2, negative 1. And our radius is going to be the square root of 16. So your center is 2 to the right and 1 down. Remember, it's the opposite. and then you go a radius of 4 up, 4 left, 4 down, 4 to the right. Now finding extra points along this is a little trickier. So you just want to draw your circle, really thinking about being as wide as you can. The common mistake is when you cut the corner and you make it flat along the edge. This next one, our center, this is x squared, so it's x minus nothing, so it's 0. And y plus 2, which means that the k value is negative 2. And of course, our radius is the square root of this value, so the square root of 1 is 1. 1 times 1 is 1. So I go to 0, negative 2, and I do my radius of 1 and connect that. That kind of looks like a soccer ball. All right, just a couple more. We're going to write our equation. Now, what's different about this one? We're given a center, but we're given a point on the circle. So if you think about this, we have a center at 0, 0, and a point which is 0, 4. And we want to know the equation of that circle. Well, there's a couple different ways we can do this. We have a center of h, k. Now what I don't know my radius. I have a point on the circle, and what makes this convenient is it is vertically compared to the center point. So since it's up 4, I know my radius is 4. Another way you could calculate this is if you didn't realize that. If this is x and y, this is a point on the circle, so it's considered x and y. So we're going to take our standard form of our circle. We're going to plug in the x and the y, 0, then we're going to minus the h, and we're going to plug in the y, minus the k. That gives me 0 squared and 4 squared, which equals 16 squared. So I know that r squared is 16. And in fact, that's all I need to know. So now I can call it x squared plus y squared equals 16. And there's my equation of my circle. You could type that into Desmos to verify your answer. Okay, this one's going to be pretty much the same. We're given a center, which is h and k. We're given a point on the circle, which is not vertical or horizontal to here. So you need to know this method, which is x and y. You're given your equation. So we know our x is -1 and our h is 3, so it's x minus 3, so it looks like a -3 there. Plus the y value was 2 minus, now it's a -3, so it's minus a negative. So this is going to become negative 4 in parentheses squared. And this is going to become 2 plus 3. 2 minus a negative, 2 plus. So that's 5. And we square it. So we have 16 plus 25. That's 41. So the radius squared is 41. So we're ready to write our equation. X, and now notice here that it was x minus 3. So you can take the way that you've written it here and know that it's going to be just the minus that amount. Plus y, this is minus a negative. So that makes it a positive. So y plus 3 equals 41. Because that is r squared. Okay, last one. What's different about this one? What are we going to need to know? If they give us the diameter, we can come over here. We can make a sketch that we're 1 to the right and 6 up. We're 5 to the right and 2 down. There's my radius, or actually my diameter. So my circle is going to land in here somewhere like that. So my center is going to be something like there. So how do we write our equation? What do we need to know when you write an equation? You need to know the radius. And you need to know the center. Well, we can find the center by using the midpoint. So x1 plus x2 over 2 and y1 plus y2 over 2. That is your equation of the midpoint. So we're going to do that here. We have point x1 and y1 and x2 and y2. So we take our x's, 1 plus 5 over 2. And 6 plus a negative 2 over 2. That gives us 6 over 2 and 4 over 2, which is clearly 3, 2. So that's my center point. 3 to the right, then 2 up. That's halfway between 1 to the right and 6 up, and 5 to the right and 2 down. Now, what I don't know is what? I don't know so what we're going to need to do is the same process we did before, like we did up here. We took our equation of a circle, plugged in our x's and our y's and our h's and the k's, and we figured out what r was. That's what we're going to need to do here. I just don't have any room to do it. So we're going to do a point. We'll call that 1 minus our h and k. This is our center. So 1 minus 3 squared plus 6 minus 2 squared. That gives us r squared. This is just the distance formula. x2 minus x1 quantity squared plus y2 minus y1 quantity squared equals the distance. We take the square root of this, but we've squared both sides, so now the radius is squared. So this becomes negative 2 squared and positive 4 squared. So this, when you square negative 2, you get 4, and you square 16, or 4, you get 16. So r squared is going to be 20. 4 plus 16 is 20. So we're all done. X minus 3, because it's x minus the center point, plus y minus the center point, the k, squared, equals r squared. And r squared was 20. You did it. You always need a center, and you always need the radius.